So let's see, do any of you have questions or comments for each other that you want to bring up? Or should we, anything?
Probably
Daniel, do you have any thoughts about Cindy's allures or vice versa?
I sympathize with the bat. I mean, I can say that when it comes to bat behavior, when we examine the bat behavior and we look at the bat's adaptive echo signals, I certainly feel I understand why that's happening. We do see many analogs in human echolocators. For example, I call it targeting sonar versus orientation sonar. So orientation sonar is you're walking along, you're navigating along, you're simply keeping track of where you are. You're probably clicking less frequently and more loudly. But for targeting sonar, which involves some kind of interception of an object, be it for avoidance or retrieval or recognition, you're probably clicking more frequently, often less loudly, so as to enable you to focus in more effectively on the target and increase its signal against its background. So that's just one example of how a human echolocator might respond to its environment in a manner somewhat similar to bats.
So on this question, Daniel, of what it's like to echolocate, I'm curious about the relationship between your echolocation spatial sense of the objects around you and the auditory experiences you're having from hearing the background clicks and so on. I mean, do the clicks and so on just totally disappear from the phenomenology? Are they related in some ways to the spatial sense, so the space is somehow imbued with clicks, or is it some relationship that's different again?
You do hear the click. You can't really factor it out of one's consciousness very well. So if I'm clicking, I'm definitely hearing the click. However, I will say that many people who echolocate are, in fact, not always conscious of their clicking. So I have, or indeed of other sounds that they might be making. So I have worked with individuals who are producing signals, presumably for echolocation purposes. There would seem to be evidence of that. And yet, when questioned about this, they report not having been aware that they've been producing signals.
So is there any auditory element to your spatial sense of your surroundings when you're navigating by echolocation? Is there any sense in which it feels like sound at all, or is the clicks just separate from the spatial sense?
I'm now thinking I'm not understanding your question. There is an awareness of sound when echolocating, but I think that different people have different phenomenological awarenesses. Some people report or verbalize their experience in more visual terms, flashes of light, dark shadows, dark curtains. Other people actually talk about their experience in with more tactile language. And others might use more auditory language. And I think it might depend a bit more on learning style. It might depend a bit more on background experiences. Individuals who have not had previous visual experience may describe their environment in visual terms. Well, they may describe their environment in rich spatial terms, which have visual language, but they're not likely to use terminologies like dark curtains or shadows or flashes in that same sense.
I don't know whether either of you want to come in on this question of the extent to which echolocation is phenomenologically or otherwise like vision, and the extent to which it's like hearing.
Well, I would say in the case of the bat, it responds so rapidly and can maneuver through tight spaces so agilely that I see this as strong evidence that it has a very rich spatial representation, like vision.
Laura?
Yeah, I would also, so I think that there are also certain properties of the echolocation derived information that are very similar to visual information, such as certain spatial layouts. Other types of information, however, cannot be obtained, or at least they're more ambiguous. For example, Daniel mentioned that echolocation can also be used to obtain information about substance of the sound reflecting surface, such as, say, a piece of wood versus a spongy material. They will give rise to very different acoustic reflections. And in vision, we often think of the surface material and the shape of a surface very independently, even though they may be less independent than we think. But in echolocation, they're perhaps even more intricately linked, because the shape of a surface, and when a surface is, say, convex, will give rise to a fainter echo as compared to a flat or a concave surface. And however, one can then create a similar acoustic reflection by just changing the material. So in this way, I think we really have to rethink, or at least I had, let's say, I talk now about myself, I really had to reconceptualize the way I think about what the actual information is and how this relates to the physical entities in space.
Okay, and now we can open it up for a general question that you had there in the reaching up. Had a general question? Yeah. No. Well, yeah. In the blue. Is it blue?
Yeah. You asked the question that I had. I wanted to sort of add something to that question, which is, it seems that radar echolocation and visual reception of waveform information from the environment all works on the same two-dimensional limitation of triangulation, you know, where the information is triangulated to us, and if there's something completely blocking some information, then it can't triangulate to us. And so it makes me wonder how similar, maybe for Daniel, maybe could speak to this, how similar the mental construct that I build in my mind from all of this triangulated waveform, it's flat because it's 2D, but my mind creates a 3D model of it, and I can perceive depth from this triangulated information. And do you see the two ideas of a sort of flat way of looking at the information, if you wanted to look at it flat, and also an extruded or a depth-based way of looking or interpreting the information, the model that you have? Can you see it in both ways?
I don't think so. I think it really seems, I think if I thought about it, I could. And I've thought about it a lot. But typically as a person echolocates, they're not necessarily thinking about it to that degree. They tend to be just aware of a three-dimensional experience. Even though they may be clicking and scanning, so clicking and scanning for humans is much the same with bats. You're scanning with your signal, you're moving your ears in the same way that you would be moving your eyes. And the stimuli that are received are integrated into the brain, really into one image. It's much like retinal saccade. I mean, vision does really the same thing in terms of, or a similar thing in terms of how it moves its retina, how it scans its retina. Even if you try to keep your eyes perfectly still, your eyes aren't perfectly still. There are elements in your eyes that are constantly in motion, taking snapshots, if you will, of the environment, and the brain zipping them together into a composite image. So I'm not sure that I think the situation is similar to some degree with echolocation.
I have two quick questions about human echolocation. So one is what advantage non-sighted people have to achieve this echolocation? So obviously they're more motivated, but if we can subtract the motivational difference, are sighted people, can they learn to do this as well as non-sighted people or not? And the second question is, when sighted people achieve this, should we expect that this is achieved by visual areas of the brain or not?
Should we split the question? Yeah, so I could maybe talk to the second question, then Daniel can answer the first question. So based on the way I think about it, I would say yes. I would expect or predict that sighted people learning to echolocate would also recruit visual cortical areas to do so.
Yeah. The motivational factor is actually quite important, as is the necessity for regular practice and application. So assuming that you were somehow able to make a sighted person motivated and put them in a situation where they were able to practice this regularly, maybe you blindfold them for a month or so. Yeah, a sighted person could learn this. Many sighted people take longer at first because it would seem that the auditory system needs time to adapt. So the auditory system needs time to refine, I would guess, its temporal and frequency calculations to be able to receive, well, to be able to process the data that are received. The auditory brain in a sighted person seems to be either unaware or just dismisses a lot of this data. One of the issues that Laura talked about earlier was the precedent effect. Okay, so you have to learn to undo the precedent effect for one thing. And that takes a bit of jiggery-pokery in the auditory system probably to be able to do. And once you've made those adaptations, then yes, I don't see why not.
There is evidence that normally sighted people use echolocation already in some context, right? Like, blindfolded, walking down a corridor, people don't bump into walls and so on. So I take it the potential is already, in some sense, there.
As I mentioned earlier, I think it is hardwired. I think it's just a matter of activating that system.
And we use echoes without necessarily being aware of using echoes. We're all aware, or we have a sense of this room, the size of the room, from the reverberation.
This is a question for Daniel. Do you use echolocation in your dream?
Yes. Yes. So basically, our dreams are representations of our reality. So and to some extent representative of how we perceive reality. So my dreams are as I perceive reality. They're based on touch, they're based on hearing, they're based on echolocation, they're based on language, they're based on all of the things that my reality is based on.
Daniel, have you had the opportunity to work with young children, and do you find that they're any faster at learning echolocation or able to learn it more fully? And then also, have you had any blind students who have been unable to learn echolocation? Do you have any knowledge or speculation as to why? So,
we work a lot with children. Probably 75% of our clientele is children. We've worked with children as toddlers and infants, so very young children. I would say yes, they are more adaptable. They're more flexible. In that sense, they learn echolocation faster. They learn just about everything faster. But I think that the real index here is motivation. It's motivation and practice. It's very difficult to teach a child anything if they're not motivated and they don't practice. And as far as, yes, we've had a few blind people who really, really seem to struggle with echolocation. But we have to keep in mind that there are two elements here. One element is the actual auditory perception of differences. We have had children individuals, able to perceive the echo distinctions quite effectively, but not necessarily effectively apply that to movement. So it's one thing to be able to perceive the information. It's a different matter to then apply that information to governing your movement more and more effectively. So sometimes we've had students able to perceive things quite well, but not able to apply that to movement. Possibly they're not imaging effectively. So they're hearing the distinctions, but they're not actually imaging those distinctions. And then by consequence, they're not able to apply that image to effectively governing movement. Some individuals just do have difficulty hearing the distinctions. So for whatever reason, they may have trouble being aware of those auditory distinctions. Maybe they have an auditory processing issue of some kind. There are blind people who have auditory processing issues, just like there are sighted people who have auditory processing issues.
Alexander.
So, yeah, two aspects. First of all,
just one. Time is running out, so just ask one question.
Okay. No, it's one question with two aspects. So, first aspect, did you consider what happens in a musician's brain when he's reading a score, a music score? Secondly, did you consider what's happened in a conductor, orchestra conductor's brain when he's conducting? Because conducting means to anticipate the results of written score with the real sound, which is an echolocation, anticipated echolocation. Did you consider this aspect?
Was it the question for me? I'm not sure I understood the question in its entirety. If you could
The fact, I explain, when a musician read a score, just read it.
Alexander, try it without the microphone. Just shout.
When a musician read a score, automatically in the brain, automatically, very short, the sound is represented, not one sound, all sounds. Did you
when musicians read the score?
Yes. And so the question is whether there's a similar expansion of the anticipated sounds in echolocation. Is that correct?
Yes and no. Yes and no, because this is the mind producing the sound, anticipating what the real sound will come.
I think maybe we'll take this as a contribution and move to the next question here. Thanks.
I think anyone who's listened to a stereo system or a home theater system has had the illusion of motion from one side to the other. Have any of you either discovered or have used audio illusions in your work?
So I have not used illusions so far, but for example, so we are aware that these things happen, and for example, to take care of it, the way we, for example, design our stimuli is to make them as close to the real thing as possible, which would then include to make the recording that the person would hear it. Is it answer? Yeah.
Thank you. I want to ask Laura, since you dealing with blind people, there is attention is ruled out. Then intention and the intuition could be that which direct the echolocation. In a sense that we now establishing a theory for the intelligence of the heart, and the heart, of course, processes information, the heart receives information. And from the environment, there could be an electromagnetic waves that receive or that information to the heart, and the heart signal to the brain. And in fact, when you hit this echolation, is a conscious act. And correctly you said that you are not dealing with the unconscious, you're dealing with the conscious act and consciousness. So the theory of the heart is quietly nicely can fit in your direction. Thanks.
Thank you. I think Ned has another question. Does anyone want to comment on that one?
So as I'm sure you're well aware, in sight there are two visual systems, a system at the top of the head that processes very quickly and supposedly largely unconsciously, is much more spatial, has egocentric representations as compared with the so-called ventral visual system, conscious, slow, allocentric representations. In the case of echolocation, either in bats or in humans, does that correspond more to the dorsal unconscious system or more to the ventral conscious system, or does that distinction not make any sense, or what?
So there are certainly many visual streams, the most prominent distinction between the dorsal and ventral. There's a debate, of course, to what degree they serve different functions. We actually investigated potential different neural substrates for different spatial properties as could be derived from echolocation, and there seems to be evidence that, for example, attributes such as locations and so on activate more parietal areas which might be considered a part of the dorsal stream, whereas attributes such as shape, regardless of the location of the object, might be more processed in ventral visual stream areas. But this is work in progress.